Before moving on to DOPS, I want to talk about the rasterization and some of the options that we have when it comes to this node in particular. This rasterize, again, takes our particles and turns them into volumes. So we have a few controls in here which alter the way in which our volumes get drawn out. If we change this coverage scale, you could see that points in general will cover more ground. Same with the particle scale. If we turn this to a really small value, you can actually start seeing these points not reaching all the way out. And so you want to have a particle scale that makes sense for the amount of points in your scene. Let's just leave these two alone for the time being. And I want to show you the main setting which controls the overall resolution of the source. If we go to our pyro source up here, this is where we created the points. We have this particle separation since we use this volume scatter. Now, if we turn this particle separation down, that means the particles have less distance in between each other, and hence we have more particles. So instead of 0.03, let's try out 0.02, or yeah, maybe like 0.025, something like that. And as you might be able to see here, in this rasterize, now our voxel size is also down. So this voxel size basically takes a relative reference of our particle separation. It multiplies that times the particle scale, which I believe is this right here. And then it also divides that result by 4. So someone basically came up with a cool system for creating a voxel size which makes sense for whatever you specify right here. But you can do whatever you want for this voxel size. The main thing is that this voxel size needs to make sense for how spaced out these particles are. Now that all being said, you don't want your source being too heavy, because a heavier source is going to cause your simulation to go a lot more slowly. So the rule of thumb here is to only use as many voxels as necessary to define the major shapes that you're trying to make. In this case, if I middle mouse, we have about 125,000 voxels, and I think that this is actually a pretty decent number to get us started. Let's recache this out, and then we'll jump into DOPS. Now let's head over to our DOPNet and see what's going on over here. Again, this volume source is going to pick everything up from SOPs. You can see that path up here towards the top, right there, and it's also preparing 3 fields for the pyro solver. We have density, we have temperature, and we also have velocity. Now we actually haven't made the velocity attribute yet, or the velocity field yet. So more on that here later, because I'll get to that in a little bit. But for right now, let's just pay attention to density and temperature. Now, the way that these fields work is that we have this source volume. This is basically the volumes we made in SOPs. And this is the name that that field has. So right now, our density and temperature are the same values because we made the noise the same for both. So one thing you could do is down here in temperature, this won't make any difference, but just to show you what this does, I could say density, and that will do the same exact thing. It's just saying what's it called in SOPs, and now it's going to make this field for DOPS, which is temperature. Now for right now, don't worry about the SOP mask and DOP mask. If you had additional volumes that control where these fields are allowed to go, then you can use them as masks right here. But again, for right now, I wouldn't worry about it. Also, we have this operation. And what this means is that how do you want to combine the field that's coming into the source with what's already in your scene? So this wispy smoke had turned this operation to maximum. And what that's basically saying is bring in whatever SOPs has on every single step, but only go with whatever the maximum value is on that one spot. So it compares the SOP density, and it compares whatever density lives in DOPS, and it figures out the maximum, and it just goes with that. So you can have all kinds of operations to specify exactly how you want to blend stuff with SOPs and DOPS. But again, for right now, that's not really something we need to worry about. Let's just set this to add so that at every single step, it's just going to add more smoke wherever we have a high density value. Okay, so that all being said, we have density and temperature. Now, I actually haven't told you what temperature does yet. So let's turn this off for a second. And if I press play, you'll notice that nothing really happens. I mean, it kind of looks like stuff is happening, but it's not. It's just a low resolution thing of what you see right here. And basically what this means is that without temperature, we just have smoke that's being added in, that's our density, and there's really nothing moving it around. So this temperature is the main thing that's driving the movement of our smoke, and that's where we're going to start dialing in our settings. Let's turn this back to 1, and now as you can see, we have smoke that's rising up. So the temperature field basically tells other voxels that it should be buoyant, or it should move upwards. If we go to our pyro solver down here, and we go to the simulation tab, we have this buoyancy direction, and that's telling the temperature what direction it should throw these voxels. If I, let's say, put this going in the Z direction, now temperature will throw things in the Z direction. It's probably a bad example because you can't really see it from this angle, but there you go. Now it's doing that. So there you go. That is more or less the volume source. Now you can also source particles right here if you wanted to throw particles around in your simulation. That's perfectly fine as well. And you also have this instancing, which for right now, let's not worry about. One last thing about this volume source before we move on is that you also have a bunch of presets. So if you wanted some volumes that would represent a collision or a pump or all these different things, which can be used again with a pyro solver or with a flip solver, whatever the case might be, you do have a few presets which will create these fields for you. Or you can always create your own fields by pressing this plus icon and then filling out the data of whatever it is you're trying to do. In the next video, let's check out the smoke object.